Hello again, students. This video we are talking about significant figures. You know how you get these long strings of numbers on your calculator and you're not sure, should I round it off? And then when I choose how to round it off, how do I know which digit to stop at? So the rule for that in science, since we're discussing measurements that you take in science, is that significant figures consist of all of the digits that we know with certainty plus the first uncertain or estimated digit. And what that means is I might see my ruler, I might measure something up to this centimeter, maybe 8. Let's see, I can go like up to 8, but maybe the thing I'm measuring is like just after it. So I know for certain it's right there. Let's see, this is tricky using the camera for this. Okay, so let's say I measured it right there. I know for certain it's 9.2 centimeters, but I don't know if it's exactly on that line or right before it or right after it. So I have to say 9.25 would be, so I would use 3 because I had to estimate, oh, it's probably a little bit past 9.2. So when we know which digits are significant, this prevents a scientist from reporting a value that's more precise than the equipment used to gather the data. So I was just showing you my equipment is a ruler. I can't say 9.2356 because that's a way above the precision for my ruler. Or my scale, the digital scale in class only goes up to 100ths of a gram, so we can't say a calculation that includes 1,000ths of a gram. So this calculating experimental results usually requires a variety of mathematical operations, such as, so when we add, subtract, multiply, or divide, we use lots of measurements, and these all have varying levels of accuracy. So there are different rules for determining how many significant digits are in a calculation or a measurement. So we always say that non-zero integers are significant, like the number 275 has 3 significant digits. For zeros, sometimes they are significant and sometimes they're not. So if they're between non-zero digits, those are called captive zeros, and those are significant. So this number, 87,009, has these 2 zeros are significant. So we say it has 5 digits. Zeros preceding non-zero digits are leading zeros, and they're not significant. These are mostly just acting as placeholders for a decimal point. So we say these 2 zeros here in front of all of these non-zeros are not significant. So this value has 5, while this value here has 1 significant figure. Zeros at the end of a number are called trailing zeros, and these are only significant if the number has a decimal point. For example, the value 85.00 has 4 significant figures because the 0.00 tells us how precise our measurement tool was. It could have measured up to 100th of a unit, and it's exactly on 85.00. So that's significant. And the value 9.00000, wow, this measurement tool could measure up to the 100 billionth of a unit. That's a very precise measurement tool. But this value, 2000, only has 1 significant figure because the zeros, we imagine the decimal point would be here, but we didn't use a decimal point, so there's only 2. Exact numbers, like conversion factors, things we count, like how many potatoes you have. And defined values are assumed to have no uncertainty and therefore have infinite significant figures. Okay, so with those rules, we're going to try to count how many, or rather, which, let's place each measurement in the correct box according to the number of significant figures it has. So we would say all these zeros are leading zeros, 0.00009. So we would put that in this box. Centimeters. This one, these are captive zeros, so they are significant. So this has 4. This 0 before the decimal point is not significant. It's just a placeholder for the decimal point. So we'd say this has 3. These zeros after the non-zero are not significant because there's no decimal point after it. So we'd say this has 2 sig figs. In this one, 784.0000. Even though these zeros are after the decimal point, these are significant because they tell us how precise our measurement tool was. It could have measured up to the thousandths of a gram. That's a really nice scale if it can measure that precise. And this one has 5 significant figures. 1, 2, these 2 are captive zeros, and this is a 0 after the decimal point, so that is significant. So we'd say this number is, all of these zeros are significant.